Okay, this is going to be a video that's just a really quick review over all of limits to show you all the little ins and outs and things that can happen as a refresher, maybe before a big test or something. So here are the first 6 examples. These are just very straightforward, find the limit. And within every single one of these problems, you're going to see the different stuff that can happen that you're supposed to know, okay? So remember, with every limit, the first thing you want to do is try direct substitution. So in other words, plug in the value, because if you can plug in the value and if you get a number, then that is the limit, okay? So when I go and plug all of these in, I'm going to have 3 pi squared minus 2 pi plus the cosine of pi. Now, what is the cosine of pi? Well, it's the x value at pi, and that is -1 if you know your unit circle. Now, this is a number value. I don't know what it is because I don't have a calculator, but this is a number, so this is the limit, this whole thing. If anything went together, of course, you would combine like terms. Okay, but that's fine. That's a perfectly fine answer. Number 2, we first plug in the 0, and when I do that, I get 3 over 0. Now, 3 over 0, that is not a good number. In fact, that is undefined. But since it's a number other than 0, over 0, I know for sure this is going to be does not exist. Now, why do I know that? Because when this situation happens of another normal number over 0, it is a vertical asymptote. Okay, so that's good to know, because if this question also asked about continuity, which often they do, then you would say it's not continuous at 0, or it's discontinuous at 0, because it has a non-removable asymptote. So that's what this means, non-removable asymptote. I'm sorry, non-removable discontinuity. Blech. Okay, sorry about that. Okay, number 3. Now I'm going to plug in my 1. So when I plug this in, I get 0 over 4. Okay, well, 0 over 4, even though that feels weird, 0 over any other number is just 0. So that's perfectly fine answer, okay? Number 4, I plug in the -3, and when I plug in the -3, I'm going to get 0 over 0. Now, this is where you have to be careful. I'm going to put a big star over this. 0 over 0 means undeterminable, and more work has to be done. Okay, there's one of 3 things that usually you do. Either you do some factoring, or sometimes if it's a radical, you can do the conjugate trick. These should ring a bell, guys, and if you don't know what I'm talking about, go look back through your notes. The third one that often pops up for undeterminable is, what is it? Oh, it's usually like fractions within fractions, and those usually just require common denominator algebra and some canceling. That's what usually happens there. And the other one is maybe it's a special trig problem. Okay, well, this one that we're looking at a glance, hopefully you can tell it's going to factor. So if I factor the top, I'm going to get 2 times x plus 3. Okay, so that's going to replace that. On the bottom, this is a difference of squares, right? So it's just x plus 3 times x minus 3. And notice when you do that, guys, that something's going to cancel. And this should happen if you get 0 over 0 on one of these problems. Something's going to cancel, and then what that allows you to do is it allows you to take the leftovers, which in this case, the leftovers are, I'm out of room, I got to erase, it's 2 over x minus 3. Now try plugging in that number, and sure enough, you're going to get a real answer. And we're good to go. That's going to be the limit, okay? What has happened here is that when a factor cancels, it creates a hole. So it's like the entire rest of the graph was trying to approach this spot, but it just had a hole and it had to jump over it. But remember, with a limit, it may not exist there, but there is still a limit there, okay? Because you're approaching it from the left and the right. Okay, number 5. If you tried this by plugging in, once again, you're going to get 0 over 0, which means something needs to be done. Now, with this problem, I can't factor. There's no common denominator trick. There's no, what was the other one? I can't remember. But what this is going to be is one of those special trig ones, okay? So what you're supposed to know is that if you see this, the answer is 1. Okay, that's something to memorize. So what you do is you compare this to this, and you just kind of play with it. Now, if you look at all of this 2/3 is just a random fraction that was multiplied. So it's almost like you're pulling numbers out of this, and then that way this part still goes to 1. So like this, and this all still go to 1. You do have an extra 5 to contend with, but if you just multiply the 2/3 by the extra 5, by the fact that the limit of that is 1, then you are going to get 10/3, and that is your answer. Okay, so hopefully that didn't trip you up too much. The other one that you're supposed to know, by the way, is the limit as x goes to 0 of 1 minus cosine over x is 0. And these are interchangeable, by the way. These could be in either order, but this is another one that you need to memorize. Okay, and number 6, I gave you a piecewise because these show up a lot, and it might be asking about continuity, it might be asking about a limit. In this case, it's a limit problem. So here's the deal. When I look at this, it's a line everywhere except when x is 2. And then when x is 2, there's a random point out in space. So the graph might look a little something like this, and then it'll skip over, I don't know, something like that. So the thing is, and I know my graph probably doesn't match exactly, but this is what's happening. Now, is there a limit still at 2? Well, yes, there is, because you're still approaching it from the right and the left. This is just a random point, okay? So to find the actual limit, just take your 2 and plug it into this equation anyways, because even though it's a whole, because that's what that's telling you, you can still know where you're supposed to be approaching. And in this case, it is -2. Okay, now if this question had asked me for f of 2, that wants to know exactly where the y exists. And the y exists on this problem at that 7 right there. Okay, so there's a big difference between those. If it asked about continuity, okay, is this continuous or discontinuous? Well, there's a hole, so it's discontinuous, and you would call it a removable, because it's a hole, discontinuity at x equals 2. So those are discontinuity. So those are a few things that can happen with continuity and limits above. Let me think of other quick review type questions. If you're given an equation, and you are asked to find the continuity or wherever it's discontinuous, and you have something up here and something down there, remember the idea is to factor and cancel, okay? Because if it factors and cancels, it equals a whole, which is a removable, like I just said above. And if there's anything left in the denominator that doesn't cancel, then that's equal to a vertical asymptote, therefore it's non-removable discontinuity. So that's all terminology that you need to know, okay? And from a picture, if you have, 1, 2, 3, 4, 1, 2, 3, if you have a graph and it's doing all kinds of crazy stuff, okay, let's say that this is your problem, then if you could be asked all kinds of stuff. Remember, if you're asked for an f of something, like maybe f of -1, that is the literal y value that you land on, and that's always going to be the closed circle one, okay? So the closed circle's at 0, so that needs to be my answer. If you're asked for a limit, like let's say the limit as x approaches 2, we'll call this f of x. The limit as x approaches 2, well, I go to 2, I go down to my graph, and it looks like it's trying to get to -3. Now, I'm going to answer the question with -3 because even though there's a hole, as long as it's approaching from the left and the right, then it's fine. I mean, that is the limit. So why is there not a limit as x approaches -1? Because right off the bat, I'm going to tell you there is no limit there, okay? Well, it breaks the rule that I just said. You have to be approaching the same thing from the left and from the right, and they are approaching two different y values. You might be asked to prove why the limit doesn't exist. And if you are asked to prove or justify yourself, all that you have to show is that the limit as x approaches -1 from the right is equal to something. So what is that? X approaches -1. This little plus sign means from the right, remember. That's trying to get to 0. But the limit as x approaches -1 from the left is trying to get up here to 1. So I would show the limit from the right, the limit from the left, and then just say the limit from that side does not equal the limit coming from the other side. This would be a perfect proof for why something does not exist. You're just showing why they don't match up. Now, what if you're asked for this is called a one-sided limit. Remember, one-sided limit. What if you are asked to do a one-sided limit and you don't have a picture, okay? If you don't have a picture, you've got to be really careful. So maybe it's like x approaches -2, and then you see that. Maybe it's like x plus 2, 3x plus 5. Okay, if you're given this problem and you try to plug in the -2, you're going to get a 0 on the bottom, and it's a number over 0. So you're going to be tempted to say does not exist, okay? And that would be the answer if this negative right here was missing. So let's be clear. If that was missing and you tried to plug that in just like we did above, you'd have a number over 0. It means it's a vertical asymptote, and you say does not exist. But when they stick a little symbol like an X, like the the plus or minus, that means you need to really analyze from the left or from the right. Is this graph, headed up, or is it headed down? And you are allowed to answer with either plus or minus infinity. So you have to figure out which one is it going to be. Well, to figure out which one it's going to be, you have to know that this means from the left. So you need to think number line and pick me a number that's to the left of this. So I'm going to go with -3. -3 is to the left of that. And I'm going to take -3 and I'm going to plug it in right here. And I'm not looking for an exact answer. I'm looking for if it's a positive or a negative. Okay? So -3, that's going to be negative on top. And it's going to be negative on bottom. So what's a negative over a negative? Well, it's a positive. So my answer is positive infinity. So that's all you're looking for. Pick it, plug it in, see what you're getting. Okay, the last thing left, I'm trying to make this under 15 minutes. The last thing left is limits at infinity. And that would be any time you see this. You see, okay, well, limits as x is approaching infinity. So there's a couple of rules. One of the rules is if the, I just compare exponents pretty much always. If the exponent's greater on bottom, it's always 0. If the exponent is greater on the top, this is where you, the answer is either positive infinity or negative infinity, kind of like the one we did before. You need to pick a number that's, think fairly large, I guess. I'm going to go 10. To me, 10 is a large number. I'm going to pick 10 and plug it in. 10 squared minus 1, that's positive. 3 times 10 plus 1 is positive. A positive over a positive, positive infinity. So you're allowed to answer infinity when you see an infinity down here. Okay, so that's rule number 1. Rule number 2. Rule number 3 is what if those exponents did match? So 3x squared plus 1 over x squared minus 1. Whenever they match, you just take these two terms and reduce, and you just go with the coefficients. So that's just a 3 over a 1, which is a 3. So you could do it just like that. So there is a nice quick review for everything. I've seen a couple of tricky limits to infinity problem. Let me show you one I have in mind right here. I've seen this on a test before. So let's say that you see this and you're like, oh my God, there's a radical, I'm freaking out. Okay, don't freak out. I want you to actually still take the biggest term on top and the biggest term on bottom and reduce, okay? So this would be a 3x over this, what's the square root of 36x squared? Well, it's just 6x, right? Now do the comparison. Okay, the exponents match, so guess what? 1/2 is your answer. 3 over 6 or 1/2. All right, that is a very quick review. It doesn't cover everything, but it would be a great refresher before you take your test. Look back at your notes aside from that at different definitions and things, but good luck, guys. That is the basics.